Here you can see an electric circuit with a battery and a key. There is a magnetic needle placed below the current conducting wire. Right now, the magnetic needle points at the magnetic north of the earth. But once the circuit is switched on, we can see that the conventional current flows from positive electrode of the battery to the negative electrode. As the current flows, we see that the magnetic needle fluctuates and shows some different direction. Now, why do you think this happens? And how does the electric current affects the direction of magnetic needle? Well, the same questions disturbed Oesterd, and because of this, he thought that there must be some relation between electricity and magnetism. He also saw that as we take the magnetic needle away from the wire, the needle comes back to its original position. This shows that there is some magnetic field that is produced by the current flowing through the conductor. This is known as the magnetic effect of electric current. Look at the circuit given. It consists of a battery, a variable resistance, an ammeter in series, and a key. The conductor wire is made of thick copper. A cardboard is placed around the wire such that the wire is perpendicular to the plane of the cardboard. Now switch on the circuit and place a magnetic needle on the cardboard at different places and mark the direction of the needle with a pencil. You will see that the pencil markings give the direction of the magnetic field around the current carrying wire. Now what if instead of magnetic needle we spread some iron filings? The iron filings arrange themselves in a circular manner around the wire. Can you tell why this happens? The iron filings actually arrange themselves along the magnetic lines of force.